With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi, the question is, are DC motor work on the principle that a current carrying coil when placed in the magnetic field experience a torque? The arrangement consists of the coil suspended in the region of magnetic field. When a current is placed through the coil, it experiences a torque and start rotating. A single arrangement as shown below. Clear? The coil rotates under action of the torque. The current is supplied to the coil by an arrangement of two sliding contact and a slip ring. As the coil rotates, the magnetic flux linked with the coil changes. This leads to the production of the induced EMF E in the coil. By the Lenz law, the induced EMF opposes the applied voltage and therefore it is called back EMF. If R is the resistance of the coil, the current I flowing through the coil R at any instant is given this. I is equal to V minus E and divided by R. And V is what? Applied voltage, and E is what? Back EMF. The back EMF is the developed due to induction, and it is directly proportional to the speed of rotation, and it is directly proportional to the speed of rotation of the motor. This, and there is a continuous power loss, and power loss is what? I square R in the motor in the form of the heat. So this I square R is in the form of the heat. So it is given about the DC motor. Now question is this: the mechanical power output of the DC motor is maximum when the current through the motor is. So at the maximum power we have to find the current. Clear? Now, as we know, this mechanical power is equal to PM is the mechanical power. So this is equal to this V into I, this is the armature current, minus loss, and this is equal to I square R. This is the mechanical power, expression for the mechanical power. Clear? Now, for maximum, we have to differentiate this. So for maximum, we can write dPm divided by, we can write this is what? Di should be equal to 0. For maximum, this differentiation of this should be equal to 0. It means we can write this differentiation of Vi with respect to the current. So this is equal to V and minus 2 into I into R, and this should be equal to 0. From here we can find the I value, and this I value is equal to V and divided by 2R. So this is the current at a maximum power, we can see, and I is equal to V and divided by 2R, we can write. Clear? So this. Now we can find the back EMF, and the back EMF is equal to this at a maximum power. Back EMF, let us consider EB is the back EMF. So this is equal to V minus I into R, and from here we can see that IR is equal to what? V by 2. From here we can see IR is equal to V by 2. So EB is equal to, at maximum power, this is equal to V minus this V by 2 we can see, and this is equal to V by 2. So EB is equal to, from here we can see that this is equal to V and divided by 2. Clear? So this. So back EMF at a maximum power is this, but according to question we have to find the current at a maximum power. So this is equal to V by 2R. So this is the required answer for this question. Hope this answered the question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.